Come on, kid. Oh, it's frozen. Grab the remote. Freeze is on the very bottom corner. Thank you. Perfect. So, listen close. Listen close. Everybody look up. Make sure your cell phone's put away. Okay, it is extremely critical in this class, listen close, that you do the homework in the right way. The homework is only 10% of your grade, but the test is 80% of your grade. And if you do not study properly prior to the test, the class will eat you alive. Like, I'm not kidding. Like, it's different than other high school classes you've had. I'm going to give you a test, 25 multiple choice questions. Every answer has been carefully constructed to be something that you would likely choose if you don't understand perfectly. So it's crucial you do the homework in the right way. Okay, so don't think of the homework as a checklist item, like I have to just get it done. You have to think of each and every homework problem as a practice test problem. You look at the problem, okay, if this were a test question, here's what I think I would do. You do it. You only use the answers in the back to verify that your thinking is correct. You don't use them to figure it out. If you're doing that, you're in trouble. Because on the test, there's no answer to turn to. You can't do that. Next thing, look at me. Okay, this first test is multiple choice, but the actual AP test is written, half of it. Half your points come from a written section. So I have to get you to use proper notation. If on this homework assignment, Timmy was asking me, if you didn't use the proper notation, don't go back and redo it. I hate going backwards. We want to go forward. But be aware that I wrote the notation out like you see it, because it actually is critical that you do that. So on future assignments, pay really close to how I'm telling you to write out the notation, because they will grade you on it. And here's the difference. And Mr. Reckley will jump in and correct me if I'm wrong. I don't want to misspeak. Prior to calculus, it's very common for teachers to look at written work and say, well, there is work, so that's 1 point. It seems generally correct, that's 2. Oh yeah, you did make a mistake, so that's 3 instead of 4. So you get 3 out of 4 for, you know, kind of having some work and generally correct. And AP test, 0. I'm not kidding. Like, you make a mistake in notation, they won't give you the point. Like, it has to be right. So I'm having you write this out as you see it in the answers to get you really primed for what am I going to have to write on the written section. And it paid off big time last year. Because last year there was no multiple choice section. The entire AP score was based on your written work. And so I was super proud of my students because from the beginning they had learned that, hey, to get the points on the written section, I've got to write it correctly. And that's why the results were so good, even in a COVID year. So, so anyway, if you didn't write it out, like you got it done, but you didn't write it out, don't go back. Just keep in mind that as I show you the proper notation, make sure you're following it. So, questions? Okay, next thing about homework. Okay, I give 2 different kind of rewards for homework. The first one is you come back to class today, if you can tell me that you have done your honest best to finish the packet, and you know maybe you have 1 or 2 that you're having trouble, maybe 2 or 3 you're having trouble with, that's okay. If you've done that, I pay you extra credit for getting it done, okay? If you haven't done that, I don't pay you the extra credit. Then on Friday or Tuesday, I'm going to ask a second question. I'm going to say, have you finished each and every problem? And I'm going to ask if your notation is good, but again, don't worry about going backwards, just do it going forward. I'm going to ask, is your notation correct? Have you checked every answer? Do you have 0 questions on any problem? If you can answer yes to those questions, I'm going to give you 10 points for the homework. But I give you a few more days before I ask that. So the first time I'm just asking, did you do your best to finish it? Yes, I give you extra credit. Friday or maybe Tuesday, sometimes even Thursday, it just kind of varies depending on the difficulty of the assignment. I ask again, hey, on this Buff homework, can you honestly tell me everything's done? I have no questions, I've checked every answer. If that's the case, you get 10 points. It's 10 or nothing. It's not like you get part credit. It's just 10 or 0. So. And then if you're running late, of course, if you try to finish it after that, it's half credits. Questions about the homework? So what I'm going to do now really quick is you're all going to turn to problem number 27. Just put it on your desk. I just walked by and I just asked you, did you finish the homework, yes or no? Yes, I pay you extra credit. I take a glance at your notation. No extra credit. So real quick. Finish?
Yeah.
All right, new packet. Look up. Okay, I'm passing out the new packet. As I'm doing that, you need to put in your notes. This is already in your notes. This is in the white packet. But the 4 colored lines at the top, 1, 2, 3, 4, that's what we are talking about today. So make a note of that. If you want to take a picture, that's fine. If you want to write it down in your notes, that's fine. Your choice, but you'll need to know those 4 steps. So do that while I'm passing this out. Allie, when you go So this is the homework for tonight. There are only 21 problems. One thing to be aware of, I've tried really hard over 14 years to just continually reduce the number of homework problems to as few as possible, but still enough that I know you'll be successful in many if you stay with me. I've tried to make it so there are very little redundancy among problems, meaning each problem has some different quirk to it, so you don't ever want to skip a problem. The one you skip is likely to be the little quirk that you'll encounter on a test. So. Greatest hits of Costco. So I'm just watching you take notes. When everyone's done, we'll start talking. So. If you're having a snack, just make sure you pull your mask back up between bites. You know. My neighbor tested positive. I haven't been close to him or anything, but it's just, I don't really want to spend 14 days in my basement like he is. So. Plus, it's really hard for you if I'm not here, so no offense. Okay, here we go. Good luck. Today, good news is we're not doing anything new really. We're still just finding limits. Okay? What's different is in the previous homework you were given a bunch of problems where the function was presented as a graph and you had to identify the limit from a graph. You also had some problems where the function was presented as a piecewise formula and you had to find the limit from a piecewise formula. Today, all of the 21 problems, the limit they're giving you is just a single formula. Like this example on the board. So put that in your notes. Leave a decent amount of space. We're going to start doing some writing in association with that. That's the only difference today, really. Another difference is I have to give you some experience on identifying horizontal asymptotes. because they like to have a question on the AP test that deals with horizontal asymptote. They almost always have one in the multiple choice section. That's tends to be a little tricky, but as long as you understand the idea, you'll be fine. So here we go. It's a limit problem. Oh, other new thing. This limit is not approaching 5. It's a limit as n. They used n instead of x. That's no big deal. N is approaching infinity. So this first item in your notes becomes relevant. When you are finding a limit, I have found on the AP test, if you follow this sequence of thoughts, you really have about a 99% chance of answering any limit question they give you. If x is approaching positive or negative infinity, we want to first compare terms that add. Okay, this is a bit redundant. Terms always add. So saying comparing terms that add, it's just because I found students had a hard time remembering what it meant by term. Student last year, Amanda Lindstrom, made a sign that helps. She just says, look, if you have a thing plus another thing, those are terms. If you have a thing multiplied by a thing, those are factors. So as I look at this, I can notice that, let's see, 3, that's multiplying by n cubed. So those two are factors. However, I could also look at it like this. 3n cubed is being added to, the addition sign is assumed. You can think of it as being there. It's being added to negative 5n. So those two things are terms. So when it says, if x is approaching positive or negative for infinity, I want to compare terms that add, I'm comparing the two blue terms. Questions so far? Cool. And here's what I notice. If n gets really, really big, both of these get really, really big. However, because of how power functions work, n cubed is a power function, 5n is a power function. The power function with the highest numerator will grow much, much faster than the other. And both will become immensely large, but one will become so much larger than the other that in terms of finding a limit, I can ignore the smaller of the two terms. So on your paper, it is crucial that you write equal. You have to have the right notation. On the written section, if you forget to write equal, they will not give you the point. They want to see that you understand one thing is equivalent to the other. Limit, you have to write limit. N approaching infinity. Now I just write 3n cubed. Because as n approaches infinity, the same would be true if n were approaching negative infinity, by the way. For power functions, it doesn't matter whether n is becoming very large positive or very large negative. The highest power function will dominate. Using the same type of comparison in the denominator, I can say that the dominant term is n cubed, not the negative 2n squared, not the plus 1. That's what I mean by saying we're going to compare terms. Question? Step 2 says now factor and divide if possible. So your next line looks like this. Equals limit n approaching infinity 3 over 1 multiplied by n cubed over n cubed. Question? Oh, please. Cameron.
Wouldn't the n cubed just be like canceled out because it's like n cubed over n cubed where you're just separating them?
So I have a little bit of a personal preference here, but it's rather strong. So a student made a sign for me. 3 tallies for Cameron. It's a really good question. I personally, it's just a personal thing, but I hate the word cancel. In my opinion, nothing in math ever cancels. This divides. Like, it doesn't matter how large of a value I plug in. Something divided by itself is going to divide to make 1. So I really, now the AP grader will be fine if you do the other, but I just hate it. Like, I feel like it leads to a lot of mistakes. Here I don't have any problem understanding what's happening. This is going to become 1. 1 times 3 is 3. So this limit, you have to have equal again. This limit is equal to 3, which is telling me that as the n value gets extremely large, the y value will become very, very close to 3. Please, Thomas.
Should we write limit and then go to infinity and then 3, or just equals 3?
Let me say why it's just equal 3. It's perfect. 3 talents. They're asking me to find this limit. I am declaring that because n is approaching infinity, this limit here is going to be exactly the same as this limit. So I have to have the equal sign and I have to have the word limit. Then I'm declaring that, oh, by the way, that's also exactly the same as this limit, but that limit's value is just 3. So this is just equal to 3. I gotta write limit again.
Sorry, how come on the last homework we did that like that? We still have to write limit as f of x in x equals, or sorry.
Yes, no, I understand what you're saying. I think
How come on this one we can just write 3?
the last one, what we did is this. We'd say the limit as x approaches, I don't know, 3 or something, of f. Is that what you're remembering?
Yeah.
And then we'd say that's 7 or something like that.
Yeah.
We're actually doing the same thing. We're putting on 2 different lines. So here is the limit portion. Just keep asking, Thomas. This is a really good question. Here's the limit portion. So there's our limit notation. Here, the function was defined as a graph or as a piecewise formula called f.
Okay.
So we wrote the formula. Here we're writing the formula we're finding the limit of. Does that make sense?
Yeah, okay.
And then we just say equals that.
Oh, okay.
You
Sorry.
see it now?
Yeah, that's quick. All right.
Perfect. Please.
So do you not need like any of the other terms in the first equation to solve for it?
So the huge idea, Christine, 3 tallies, is this only works if n is approaching infinity or n is approaching negative infinity. If that's true, when these 2 terms are added together, you have to remember infinity means unbelievably large. So you imagine some number that starts over here, and we write it clear across the board. Well, this portion of that big number is like just this little spot way over here. So it is adding something, but it's adding such a small amount in comparison to the other that we can neglect it, only because we're finding the limit. Does that help a little? 3 tallies. Anybody else? Okay. On the homework, you've got to have practice with finding horizontal asymptotes as well. Hence, item 4. So to identify the horizontal asymptote, this picture really is from the other notes. Let's pull that out of the way. You say, look, if n is approaching infinity or negative infinity, it's exactly the same for power functions. I'm still going to get to here. Okay, like this neglecting, like I said to Christine, the neglecting of the non-dominant terms happens whether n is approaching positive or negative infinity. So it gets me to here, gets me to here. So really, if this is like really, really negative cubed, divided by really, really negative cubed, still 1. So I write in my homework that as x approaches infinity, y is approaching 3. That's what this means. I should really put an n there, sorry. And as n approaches negative infinity, y is also approaching 3. So this function has a horizontal asymptote at y equal 3. And in the homework, that's how you'll see the answer expressed. The answer will show the value of the limit. That's one part of the homework question. The answer will show what's happening with the horizontal asymptote. Please, Andrew.
How do you know that the horizontal asymptote goes to negative infinity as well? Because then there's like a plot. I don't know.
No, you're fine. Don't worry. It's in this note that's in your white packet. Last year you learned that horizontal asymptote, like identifying and Mr. Rucker will correct me on this as well. Identifying a horizontal asymptote is identical to finding end behavior. You're just trying to figure out, as the graph goes way that way or way this way, what's happening. So that's why I'm having you check both directions.
So how do you check the other direction?
So how you check the other direction, three tallies. You start by saying, well, this is my formula for finding the y coordinate. So if n is very, very negative, these are power functions, I can still do this comparison and say this one will dominate. And this one will dominate. Oops, wrong pen. Like this. So that allows me to say, well, if this were negative infinity, I'd still have this. Factoring gets me to here. This is negative infinity, and then I say, okay, if I plug in negative infinity cubed over negative infinity cubed, the key thing is I'm plugging in, it's a big number, I don't know what it is, it's very negative. Something divided by itself is going to be 1. So I've now confirmed to my satisfaction that if this is a very large positive number or a very large negative, this will be 1. 1 times 3 is going to be 3. That's your question? Perfect. Anybody else? Awesome. Next one. So let's go to the next example then. This one's awfully similar. Yeah, let's just do it quick. So very similar. Write this in your notes. So x is approaching infinity. So I can compare terms that are adding again. Okay, I want to give out as much extra credit as I can. So this is a little thing I do all the time. You raise your hand, you start explaining what I should write. I'll listen and I'll probably stop you at some point, pay you 3 tallies, and then go to another person. It really helps me see if the conversation can bounce from person to person to person and we can figure out the problem without any struggles, then I feel like everyone's understanding pretty well. So somebody start me off, I'll pay you. So let's go Ainsley up.
So you write x squared over negative 4x squared.
Don't forget the limit.
Oh, the limit, yeah.
You're good. So Ainsley, correctly noticed we're approaching infinity. Oh, shortcut. 3 tallies for Ainsley. You have to have correct notation. However, the graders are not really picky on how much you write. So you can skip some lines. Like you could do this. You could say, well, I know the dominant term in the numerator is x squared. I know the dominant term in the denominator is negative 4x squared. I can see how the factoring is going to work, so I'm just going to write this. Again, don't cancel. I hate that. I had a teacher get mad at me once. She literally stops me in the hall. She's like, I was in class. And I'm working some problem, and I go, these cancel. Half the room stood up and rioted. No canceling. So I was so proud. Okay. Questions? Please, teacher.
So when you say the dominant term in the numerator, that's the biggest term?
It is the biggest term, but you have to memorize what causes it to be the biggest term. So what I'm noticing is numerator has 2 terms. X squared and added to negative 4.
Yeah.
So as x gets really, really big, adding negative 4 does change the numerator. But as x gets larger and larger, it changes the numerator less and less. So I'm like, nope, that's dominant. Does that make sense?
Yeah.
Denominator's a little trickier. I've got this term, this term, this term. These two, as you plug in infinity, they'll both get bigger and bigger and bigger.
Yeah.
But with power functions, x to the square compared to x to the first, this one will actually get so much larger than the other. You just kind of have to trust me on this
Even
one.
though it's a negative form?
Even like this will become extremely negative compared to this being extremely positive. It'll be so much more negative than this is positive.
So it doesn't matter that it's gonna be so extremely negative, it's still just like larger?
By comparison. Yeah, math's a little weird to me. Like, sometimes we think of a negative number as being small.
Yeah.
In this case, that's not helpful. It's better to think of it as it's extremely negative,
Like absolute value then?
in a sense, although it's still negative. That's why I didn't throw away the negative. So this term's going to become very negative. This will become very positive. But the negative is so much more negative that it doesn't really make a whole lot of difference that we're adding some positive to it.
Okay.
Does that help a little?
Yeah.
It's the same question Christine had, and I know I'm not explaining it super well. It's somewhat you're just trusting me to believe that that's what happens, but it does. So please.
So it's like the one that makes the greatest impact,
Yes, they both make an impact
but that one just makes it greater.
by an immense margin. And it's hard to conceptualize it because the numbers are so large. We can't simulate it on a calculator real easily. But anyway, yes. Think of it this way, Kayla. If you were trying to calculate a precise value, you could not throw away any of them because they all do make a difference. We're just finding a limit. And we're trying to find out what happens when x grows forever, which means the number gets so large that the effect they're having just gets smaller and smaller and smaller. So it's never really disappears, just becomes so small that in terms of a limit, we're okay. Retellings. Awesome. So anyway, you can just skip to here. Then you say x is approaching infinity. So something divided by itself is always 1. Doesn't cancel. 1 times negative 1/4. The value of this limit is negative 1/4. Go ahead. Or to wait. Oh, you're good. 3 for Weston. Okay, cool. Any comment that is part of the conversation that you pay? Thomas?
Sorry, so does that mean that the horizontal asymptote would be at y equals negative 1/4, or is that they're thinking that?
Yes, look at me. Look. Here's what they're going to test you on. They're going to write a question that will seem confusing and different. But ultimately, they're just trying to see if you understand. Finding the limit of a function as x approaches infinity is exactly the same thing as identifying a horizontal asymptote. So we have identified a horizontal asymptote. That's what they're going to test you on. Perfect. I do want you checking, because they might have you check this, what is happening as x approaches negative infinity. But back to TJ's comment, for power functions, it doesn't matter. This is still dominant if x is a large negative value. In the denominator, it's a little different, but it still doesn't matter. This will become very, very negative. This will also become extremely negative. But again, it's so much more negative than this one that we can neglect everything but this term. Questions? So really, I can write in my homework now, as x approaches infinity, y is approaching negative 1/4. As x approaches negative infinity, y is also approaching negative 1/4. Hence, there is a horizontal asymptote at a y value of negative 1/4. Question? Please.
So is it just whenever you say infinity, negative infinity, it's still just going to be the same thing? Like, because that's both, like it says negative 1/4, and then in the other one it was like, it was 3, and then in negative infinity it was y also equals 3.
3 for Cameron. for tonight's homework, I'll be honest with you, because every function I give you is what's technically known as a rational polynomial, I think, or polynomial rational, I can't remember which. Because the numerator is comprised only of power functions, and the denominator is also only comprised of power functions, the behavior of the function is identical whether we go very positive or very negative. So the horizontal asymptote is the same in both directions. However, Friday's assignment has a mix. There'll be some where it's different, like this picture, where you have a different horizontal asymptote as x approaches negative infinity compared to as x approaches positive infinity. Tonight, that doesn't happen. Question? Oh, please.
So is that your final answer, the one on the left? Like,
Yes, and let me show you, like, if you look in the back of the packet, the answers look like this. So I show the value of the limit, and then I show, oh, look, there's a horizontal asymptote because of this happening, just like I wrote on the board. Does that answer your
so
question,
that's all
Alan?
your answer.
That's your answer. Did that answer your question? 3.
In the AP test, are we able to write just HA instead of horizontal asymptote?
I've actually never seen a written AP question dealing with horizontal asymptote. So I'm having you write this out more to make sure it's making sense to you. I've never seen this abbreviation because it's never happened. Like they've never had a written question, so I don't really know if it's valid or not because it's never been needed. So Zach, valid, right? 3, please.
In the answers, it said like the horizontal asymptote is like the sense. Do you have to put sense? Like, is that part of the number?
No, you don't have to.
Okay.
That's no, good question, Kayla. 3. But yeah, well, please.
Will there always be a horizontal asymptote, or like
No.
only now?
There doesn't have to be a horizontal asymptote for a given function. I know there's one in the homework tonight where there isn't. There might be more than one. I can't remember, but it doesn't have to be.
Okay.
Yeah, that's actually been tested for sure, what Maddie just said. I remember a specific AP question where they said, which of the following functions has a horizontal asymptote of 5? And then they gave you 5 choices, and some of the choices didn't have a horizontal asymptote at all. And only one of them had a horizontal asymptote of 5. So. Okay, next thing. We can skip that one. That's the one we just did. Skip that one. We've done enough of that. So let's go to here. Again, someone raise your hand. I'll pay you 3 tallies. Tell me the first thing I should be doing. Cameron.
So you gotta compare the terms. So it would be
So
5.
pause for a second. Pause for a second. 3 for.
Oh wait, you gotta put equal.
Oh, hold on. 3 for Cameron. I'm just going to jump to somebody else. You're doing great. So please remember this little saying. I don't care how many mistakes you make in class. It really doesn't matter. As long as we always figure out what the mistake is. So I really pay a lot of extra credit for mistakes. So don't hesitate to jump right in and say what you think. So tiny mistake just occurred. Like the equals perfect. We do have to write limit. But in how we were thinking, something went wrong. Melissa.
Well, it's approaching 0, not infinity.
Perfect. Uh-oh. Perfect comment. 3 for Weston. Okay, 3 for Melissa. Good timing. No, it's really, like I really like it actually. Here's why. I say all the time, AP test, you cannot be on autopilot. You can't be like, oh, here's what we do. They're always going to do something to kind of make you stop and say, no, wait a minute, something's a little different. Again, it's not a huge difference here. We're just learning. We're not doing the whole AP test yet. But yeah, x is not approaching infinity or negative infinity. So number 1 does not apply. So somebody else.
So, I think we got to factor and divide.
Sweet. Somebody else. 3 for TJ. I'm just going to keep jumping. I just want one little addition to where we go. So TJ said it. We need to factor. Stockton.
Do you factor for the GCF?
We want to try and get the greatest common factor out first. we can. 3 for Stockton. Jonah?
So when you take out the x squared,
Nice. So I write, go ahead.
x squared parentheses 5x squared plus 8.
Pause right there. 3 for Jonah. Somebody else? I just try to share. Andrew?
And then you do the same thing on the bottom, so you take out the x squared again. And then you have 3x squared minus 16.
3 for Andrea. Questions from anyone? Perfect. Now, look, the next line, well, here's my recommendation. I have found a lot of students will get stuck on problems until they write this. So I actually don't really care if you write the purple, but I have found it extremely useful if you'll write the green. I totally get that most people can see that they are the same. You're just writing it a little differently. So I'm not that picky. Either one is fine. You don't have to write both of them. But you do have to recognize that this one's going to show up all the time. This is a very special fraction. What's that equal to?
1.
There is an exception. I'll pay somebody. Anybody know the exception where that does not equal 1?
0.
Say it, Melissa. You said it.
I think she said.
Oh, sorry,
One of
yeah.
them's negative.
3 times, but no.
Okay.
No worries. Somebody else said I heard it. What's the exception?
Zero.
Please, let's go Nick Johnson.
0.
If you plug in a 0, stay with me, Nick. 0 divided by 0 is undefined. It's not 1. So as long as we plug in anything other than 0, this is 1. We're finding 3 times for Nick. We're finding a limit as x approaches 0. So what we learned last time was x will not be 0. So in terms of finding the limit, this is 1. Question? Now here's a mistake that happened last period. Someone asked a really good question. I paid him a full ticket for this one. Like, it's such a good question. 10 tallies. They said, can't I cancel these? Well, after wincing and feeling very uncomfortable because they said the word cancel, I asked this question. Okay, this says x squared divided by x squared, right? Something divided by itself is equal to 1, except 0 over 0. Just say yes or no, please. Is this x squared divided by x squared?
No.
Perfect. It's not. There's no canceling. They don't divide. So you can't. Question. Awesome. Now we're on to step 3. We have to compare left and right limits. We've already figured out that when we plug in something that's a little more than 0 or something that's a little less, this will equal 1. I need a helper? I'll just pay you to talk with me. TJ, we plug in something really, really close to 0, so a little more than 0 or a little less, and we square that. What do we get?
1.
3 tallies. Somebody else.
I don't know.
No worries. Mistakes don't matter, remember? As long as we just keep working at it.
Can you
Cameron.
say that again?
So we plug in close to 0, a little more or a little less, doesn't matter, and we square that value. What do we get?
0.
Close to 0. Close to 0.
Close to 0.
Stay with me, Cameron.
1.
Well,
That was-
3 tallies. Let's go to Charlie. Charlie, stop. Oh, I want to make sure the whole class can hear, plus the video.
0 plus squared.
Close enough. We get close to 0 squared. Is that fair? Which is close to 0. Charlie, multiply that by 5. What do you get?
5.
Close to 0.
Louder, say it.
Close to 0.
Close to 0, because you've got really, really close to 0 times 5 is still really, really close to 0. Charlie, plus 8. What do we get?
Plus 8. 8.
Close to 8.
Close to 8. Yeah.
Close enough.
Close to 8. It's not 8.
Okay.
Gotta love calculus. No real answer, just close and kind of. Seriously. So people hate, they're like, I've had so many students tell me like after 4 weeks, like, this isn't math. Like we don't ever do anything, we just talk about stuff. You know, like, where's the procedure, where's the step by step? Like, sorry. Okay. Woo! Okay. Just, I have to, quick story, we have time for one quick story. So, all teachers have their kind of moment of like, hey, I really think this was my moment where I showed that I really care about my students. Recti has a ton of them. Here's the moment where I feel like I really care about all of you. It's January, 4 years ago, I think. I'm getting super excited, just like you see me now, because I just love when it makes sense to you. And I get so excited, like, I have this little habit where when I get excited, sometimes I'll turn and I'll just like, Recti like hits his head. I can't do it. Never even tried. I'll smack the board really hard with my palm, and I'm just excited, you know. This day in January, I'm standing right here. The whole class is focused, just like you are now. So I'm just getting revved up, just more and more revved up. And I'm like, yes. I just made a fist out of just kind of making it, you know. This girl in the back, Sydney Waite, she says, Allie and Gracie, her sister, they were in school last year, right? They're like, she's like, yeah, I can just see her like, you know, getting excited. Instead of turning and going like this, I turned like this. I'm not the smallest person in the world, 210 pounds. I lean into the board like this, bam! Don't ever do that. Broke that bone right there. True story. Your sister's Anna, right? So she might, yeah. No, the board is made of like thick plate aluminum. You're not punching through it, I promise. I don't care how strong you are. But yeah, I broke my hand. I'm like, I hit the board and the class just gasped. And I'm just like, ah. And they're like, you just broke your hand. I'm like, I think it's all right. Like, can I put the pen like this? And I'm like, okay, let's keep going. Never mind, don't do that. 6 weeks of like writing with this weird cast like this. Sorry, I get kind of excited. Okay, look. Something close to 0 squared is close to 0. Times 5, still close to 0. Plus 8, close to 8. What's the denominator going to get close to?
Negative 16.
Negative 16. So this limit, so look, calculus, AP calculus, you have to make sure you don't lose track of what you're doing. You don't just do the work, you make sense of it. This is saying, when the x-coordinate is almost 0, a little more or a little less, the y-coordinate will be almost negative 1/2. That's the value of the limit. And that's what limit means. Questions? Please, Tom.
Actually, I'm away.
You're good. So I did this, I think I did this last time, I can't remember. I like to think of limits and use my hands. Look, here's x equals 0. What we just figured out is for this function, if you choose an x-coordinate that's a little bit less than 0, you get a y-coordinate that's negative 1/2, or very close. Same thing on the other side. But right in the middle, where x is equal to 0, we get undefined. Because when we plug in exactly 0, this is undefined. So that's a removable discontinuity. Because you did this in the homework last night. Left and right limits match. Value in the middle is not there. That's a removable discontinuity. Please.
A removable discontinuity is always with when x approaches 0, or is it?
No, can be any finite value. So in this example, no, 3 tallies. In this example, we were x approaching 0, but it could have been x approaching 5, or the same thing could have occurred.
But that's not what we're answering, right?
Right, no, it's perfect. I was just trying to connect to what we did last time.
Okay.
Today, homework is just asking you to find the limit,
Okay.
but also the horizontal asymptotes. 3 tallies, same group.
I'm guessing you're going to get to this, but let's say whether the limit's approaching 0 or approaching infinity or negative infinity, and the power function on top, like let's say on this problem it's x or 5x to to the 5th power, and then the bottom one, it doesn't have a matching term. Like, or it doesn't have like a matching power, so it's like, it's not even, you know, like, sorry, I might just jumping around, but.
So you're making up a new example, or you're talking about this one?
Yeah, so all I'm saying is like, let's say you make that power, like to the 4th power on top of 5, and that's all you change to the problem, like, now you can't, you know, I'm not gonna say cancel, but you can't.
I got you.
It's not the same.
I get you totally. If this is, well, gotta hurry a little bit. If this is x to the 5th, and I'm trying to solve, stay with me, I think I'll answer your question. If this is x to the 5th, and I'm trying to find the limit as x approaches 0, this would become x cubed. Hold on.
It looks like on.
Oh, no, my bad. This would still be x squared. Because we want to pull out the greatest common factor, both top and bottom. So actually we'll get the same thing. Because this would be cubed. But we'd still get to here.
Okay, yeah.
You see that?
And that would be the same with like a problem where they're approaching it at an infinity.
Now infinity, it's different. Let's keep talking. Tell me your names.
And later,
That's at Ferguson, yeah.
yeah. So are we just doing like, how do you like, plug in 0 for x, because it's approaching 0? So if it's like x approaching 4, would you like plug in 4?
Right, and you don't actually plug in 4, you plug in a little more than 4, a little less than 4. Yeah, that's item 3. Got to check left and right. Let's keep going here for a second, Thomas. It'll kind of relate to what you're asking. 3 for Thomas, 3 for Emily. We still got to do, for the homework, as Ainsley said, we've got to do remember when I say your name, you always get a tally. For the homework, we've got to do the horizontal asymptotes. So I come over here, and I write x approaching infinity. Okay, we got to rethink now. Well, from here to here, all I did was factor. So I didn't do anything it's the same thing, just written differently. Here to here, I just kind of wrote it differently. So I'm going to use this. It's a lot faster than going back, well, it's about the same, I guess. If x is getting close to infinity or negative infinity, this is still going to equal 1, because it's something divided by itself. Here's the difference, though. If x is approaching positive or negative infinity, say it out loud, please. Which of these two dominates, the first or the second? The 5x squared. The 3x squared also dominates. So I just figured out that as x approaches infinity, y is actually approaching 5 divided by 3, because these now become insignificant. The same would be true for x approaching negative infinity. So this one has a horizontal asymptote at y equal 5/3. Questions? Please.
Can you just go over one more time?
Huh?
The 5/3?
Are you comfortable, Andrea, that this line and this line are perfectly the same? These two? Awesome. So if x is going to get really, really large, either positively or negatively, this will equal 1. So I look at these two and say, well, this is getting very, very big, positive or negative. Adding 8's not really going to matter. Subtracting 16 is not going to really, so I just really have 1 times this. So I really have something like this. But that just, the x squared now can divide out.
Why doesn't that divide out?
The reason is because, come on, I've got to find space to write. As x approaches infinity, this expression right here starts to look like this. Standing in your way. Sorry, the board won't let me move. Like that.
Okay, so we could separate it as that.
Right. Because we found a logical reason for why we could neglect the 8 and the 16.
Okay.
That was, the whole key was the difference between x approaching 0 versus x approaching infinity.
Okay.
Brutality. Please, Ainsley.
So finding the horizontal asymptote, it doesn't change even when the limit is x equals 0. It just like, does that make sense? Because I feel
Yes.
like we did the same process, but just later on.
Yeah, no, perfect. So the limit question is asking you to figure out, it's all about x's and y's, like I said on the first day. We're just always talking about how do x and y relate. When we're finding the limit as x approaches 0, we're figuring out what happens to the y coordinate when x is close to 0. Okay, the y coordinate gets really close to -1/2. When we find a horizontal asymptote, we're just asking what happens to the y coordinate when the x coordinate is either very positive or very negative. So it's really the same idea, and we just have to think about it differently because of the different numbers. A little?
Yeah.
3 more. Okay, we got time for one more example. Quick hint here. X is approaching infinity. Compare terms that are adding first. Like there's a couple in the homework like this, just a quick hint. Let's go to the next one. Oh, one more time. X is approaching infinity. Compare terms that are adding first. Cameron.
So since those are two equations, would you multiply factor those together?
So I wouldn't, because I can say, hey, right here, there's a term. Here's another term. Those terms are adding. Which term is dominant?
2x.
2x.
But then on the bottom.
Well, I still have to compare these two. 2x. Which of these two is dominant?
X.
Don't forget the negative.
X.
Bottom?
X and X.
And that's how I would do it, because now it's all factored anyway. So now I can write out the factors in a way that's convenient for me. So let's see, we've got like 2/1. Come on. We'd have an x squared over x squared. And we'd still have a negative. -1/1. There's different ways you can write it, as long as you have the equivalent expression. Please.
Wait, why didn't you do like 2x over x and then negative x over x? Like, where did you get
You could have. It comes out the same. All you have to check, Emily, is that when you multiply fractions, it's just straight across. So is this the same as this? So this is, remember this is a 1 right here. So you have 2 times x times -1 times x.
Yeah.
They're the same. So I'm just spreading out the factors so I can see it better. As x approaches infinity, what's this? That's 1.
1.
Times 2 is 2, times -1 is -2. Like that. Okay, one more. We got 1 minute. X is approaching a finite value. We can't compare terms they're adding, so we factor. So there's no greatest common factor, so we got to do hippo butt factoring.
Hippo butt.
Credit Mr. Recti on that one for sure. Brain stopped working. 6 and 4. There we go. Difference of squares on the bottom. Okay, big reminder before the bell here. Listen, big reminder. The only reason you're factoring is so you can divide. So if you factor and nothing divides, factoring didn't help. But on an AP Calculus test, it almost always does. I have seen a couple of problems over the years where it didn't, but it usually helps. Good work, see ya.
That's what's up.
Okay, when the bell rang, I was partway through this problem, but I wanted to kind of finish it so it's part of the video. So I'm going to back up a little bit just to make sure that I cover everything. So I'm just here by myself, but I wanted to make sure we cover all this for the video. So I'm trying to find this limit. Because x is not approaching infinity, I cannot do step 1, which is compare terms that are adding. So instead I went to step 2. There is no greatest common factor here, so I have to do Mr. Rechte's hippo butt factoring. So I've done that here. The point of factoring is so we can divide. So I rewrote this. So it's crucial that you understand that this line is exactly the same as this line and exactly the same as this line. There's no difference. They're just factored and then kind of spread out. Now I can do step 3. Now I can find the left and right limits and compare them. So as x gets really close to -4, whether it's a little more or a little less than -4, this fraction right here will always equal 1. Because something divided by itself is equal to 1, unless you have 0 over 0. 0 over 0 is undefined. Well, the only way to get this to be 0 over 0 is if you plugged in exactly -4. But because we're finding a limit, we are not plugging in exactly -4. So, finding the limit, this will equal 1. If you plug in a number that's a little more or a little less than -4 here, you're going to get very, very close to -10. It says eraser, but it doesn't erase. That's interesting. Wow. Don't know. Hold on. Pause the video for a second. Okay, so this is going to equal, this will become very, very close to -10. This will become very, very close to -8. So what this is telling us is, as the x-coordinate gets very, very close to -4, the y-coordinate is getting very, very close to a positive 5/4. That's the value of the limit as x approaches -4. We now need to check for horizontal asymptotes. So pull this out of the way. Let's clear this off and start over. Okay, finding a horizontal asymptote is the same as finding the limit as x approaches infinity. So I want to look at this and now find the limit as x approaches infinity. So really, I'm doing this problem now. Limit as x approaches infinity, x squared minus 2x minus 24 over x squared minus 16. You don't have to write this one out. You can do it in your head. I'm just writing it out so you can see how I'm thinking. Well, if x is approaching infinity, I now can compare terms that are adding. So I can see I've got x squared plus a -2x plus a -24. X squared is dominant between those three terms that are adding. Similar on the bottom. So now it doesn't matter whether I'm approaching positive or negative infinity, this is going to equal 1. So I write, as x approaches infinity, y approaches 1. As x approaches negative infinity, y also approaches 1. So there's a horizontal asymptote at y equal 1. And that's the end of that problem. So, key to notice that this is the y-coordinate when the x-coordinate is very close to -4. This is the y-coordinate when the x-coordinate is either extremely large or extremely negative. So extremely positive or extremely negative.